Dear students, in the series of numericals, here we are continuing with the numerical. Now this numerical is based on the surface charge density. Before going through this numericals, we must know about the surface charge density. Surface charge density, the charge density which we have, if suppose we have taken this an object, if we have given the charge to this object, it will be distributed over the surface, over the length, over the volume. So there will be, one is linear charge density, another is surface charge density, and third one is here volume charge density. So surface charge density, which is charge per unit area. So sigma, which is representing surface charge density, lambda is representing linear charge density, and rho representing volume charge density. Volume charge density will be coulomb per meter cube, the SI unit of it. SI unit of surface charge density, that is coulomb per meter square, and the linear charge density will have the SI unit coulomb per meter. Now this surface charge density will also have a relation with the electric field. If we talk about this numerical now, a charged sphere as hangs from a silk thread which makes an angle phi with a large conducting sheet as shown in figure. The surface charge density sigma of a sheet is proportional to this. Now we have made another diagram. Here it is a sheet which is having a sphere. This thread is there, making an angle of phi. So there will be some force which is acting in downward direction. There will be force mg. Because of the tension, there will be one force, a component of that force which will be acting upward, t cos phi, and this is t sin phi. And the force because of the charge, means because of this electric field, there will be a force, and that will be given by q times E. So if we see here, so t cos phi, which is balanced by mg, we can take it as an equation 1. Similarly, t sin phi, which is balanced by force, that will is equal to q into E. Okay. Now there is a relationship between electric field and surface charge density. So for a parallel plate, it will have a value 2 upon epsilon naught. E is equal to sigma upon 2 epsilon naught. Now first what we'll do, we'll take equation 2 divided by equation 1. So it is t sin phi upon t cos phi, which is equal to QE upon mg. So ultimately we have got tan phi, which is equal to QE upon mg. Now you know that E is equal to this sigma upon 2 epsilon naught. So we can substitute tan phi, which is equal to, instead of writing this, we have Q E is sigma upon mg 2 epsilon naught. So tan phi, which is equal to Q upon 2 mg epsilon naught into sigma. Now these are the constant values. So sigma will be directly proportional to tan phi. Sigma is directly proportional to tan phi. So if we go through the options, here we will have the B is the correct option, that is tan phi. So surface charge and charge density is directly proportional to tan phi. This will be the correct answer. So once we need to know the relationship between the electric field and surface charge density for a parallel plate or for a conducting plate. Okay. So go through these numericals. We are regularly broadcasting the through the channel.